What's up, rock nerds? Happy Friday. This is Neil S. Turlock, geologist, here to talk to you today about the Wolfcamp Formation. The Wolfcamp Formation is the most prolific shale play in the United States, if not the world. It's driving almost all the activity in the Permian Basin. The United States Geological Survey estimates that in 2018, the Wolfcamp in the Midland Basin holds 19 billion barrels of oil, 16 trillion cubic feet of natural gas, and 1.6 billion barrels of natural gas liquids. It was deposited during the late Permian age between 280 million and 300 million years ago. The Wolfcamp Formation covers the entire Permian Basin but varies in thickness between subbasins. It is up to 7,000 feet thick in the Delaware Basin, up to 1,600 feet thick in the Midland Basin, and up to 400 feet thick in the Central Basin platform. I was mudlogging over my winter break from school between the 2016 and 2017 semesters, and I was mudlogging with this guy who was trying to tell me that there was limestone in the Wolfcamp Formation. We kept coming across this stuff, and he kept telling me that it was limestone, and I couldn't believe that it was limestone, because I would expect that limestone would be deposited in a shallow water environment, whereas the Wolfcamp Formation, to me, was a shale that should be deposited in a very deep sea or deep ocean environment where there'd be almost nothing living. So he was telling me that he knew it was limestone because of the way that the hydrochloric acid reacted with the calcium carbonate, and he would smell the fumes as the fumes came off the limestone, and he knew that it was limestone and not shale because he could smell the difference between the fumes that came off and the reaction between limestone and shale. So this drove me kind of nuts, and I was like, this guy's an idiot. There is no way that any of this is true. So I started looking into it, and I found out that there is limestone in the Wolfcamp Formation, and that it comes from like underwater avalanches or turbidite deposits or gravity flows. The limestone formed in the shallow waters near the top of the basin, and as it accumulated, it would weigh down the edges of the basin, and then the basin slope would give way in an underwater avalanche type gravity flow that carried with it a driving mix of limestone, sand, silt, and clay that was deposited deeper in the basin, ultimately forming the Wolfcamp Formation. The Wolfcamp Formation is an unconventional reservoir, which means it has to be fracked for it to produce hydrocarbons. Porosity, or void space between grains, is low, varying between 2 and 12% and averages about 6%. The permeability is almost non-existent at less than 10 millidarcies, which means there's no communication between pore spaces and hydrocarbons are trapped or locked within the pores. All hydrocarbons are generated from broken down proteins called kerogen that never decomposed when trapped in sediment. When kerogen is analyzed for its hydrocarbon potential, it is referred to as total organic content, or TOC. The Wolfcamp Formation has very favorable TOC values ranging from 2% to 8%. What does all of this mean? It means that the Wolfcamp can make a lot of oil and gas. Oil is present in the cuttings, and when you add lighter fluid to samples, a ring of petroleum slowly fades out and fluoresces under a black light. I am sure that with all this talk of shale and limestone and rocks and cuttings that you are just dying to see the Wolfcamp Formation in real life. Well, luckily for you, I've got samples of the Wolfcamp that came up over the shaker table that I'm going to show to you and explain to you, as well as a bunch of pictures that I took of the Wolfcamp Formation in cuttings under a microscope, so you'll be able to see it up close and personal in real life. Here's an example of turbidite deposits in the Wolfcamp Formation. As the underwater gravity flows blanket the ocean floor, the sediments are deposited gradationally. A fining upwards trend in grain size is seen in this hand sample. The limestone grains settle out first, followed by the silt grains, and then finally the clay grains. Here's an example of cuttings under a microscope. You can see two pieces of limestone sitting on top of a piece of shale, as well as examples of black shale and gray shale. This is a piece that came over the shaker table that shows intraformational limestone within the Wolfcamp Formation shale. There are many volcanic ash beds within the Wolfcamp Formation. In the middle of this picture is an example of an ash grain. When analyzing cuttings for volcanic ash, you put the cuttings beneath a black light, and the volcanic ash is fluorescent beneath the black light. That's going to do it for this episode of the Geology Vlog. Tune in, turn on, drop out, and thank you for watching. Come back next time for more geological madness from Neil S. Turlock, geologist.